looking at, we're right here, locked back in, linear equations in context. Okay, yes?
Yep.
All right, look, linear equations in context is going to involve that you have to read in math. Read and process. But before I get you to doing that, let me just remind you something that I've been saying over and over again. That linear equations is slope-intercept form, which means y is going to equal mx plus b. When you look at a word problem, you're not going to see the word slope. What you're going to see instead is the word rate or something dealing with per hour, per minute, per month, whatever. So when you're looking for your slope, which is a mathematical term for the number of times the variable x, you're looking for it to say something about rate in a word problem. In a word problem, you're not looking for the words, this is where it hits the y-axis. Because you know the y-intercept is just right here. But in a word problem, you're looking for phrases and words such as your starting point or where you begin. That is what's going to give you the value of your y-intercept. This is taking it step by step. We're going to talk about the y-intercept, the slope, the equation, and then apply what we get from it. First thing I'm going to say, y'all need to be listening. I'm going to tell you right off the bat, when I ask you for something, the y-intercept, I don't want you to tell me that the y-intercept is where it crosses the y-axis. Because what I'm asking for is what does it mean in this situation? So read the word problem. It says a local pool has a membership fee to use the facilities. There is an additional cost for each time you use the pool. So the graph shows the total cost of using the pool depending on how many times you visit, which means at the bottom, the number of times visited is our x-axis. The total cost is our y-axis because how much you pay depends on how many times you go. How much you pay depends on how many times you go, okay? Let's start first with the y-intercept. That's easy. Look at your graph. What's my y-intercept?
40.
Thank you. It is 40. But this is the part where I need you to tell me what does it mean in this situation. It's the membership fee. Thank you. It's the membership fee. I know that the y-intercept is the starting point. But in this problem, the starting point is the membership fee. So that's what you need to write down. It is the membership fee. The slope, I gotta help you with, because most everybody's getting the slope wrong. So please let me help you with the slope, okay? To do the slope, previously we've done the rise over run, right? Where you count up and you count over. And we've also done the thing where we subtract the y2 minus y1. So that's kind of sort of what we're going to do here. Okay, so please focus in on the y-axis first. On my y-axis, you can see that I'm starting here and I'm going up 60. So how much money is difference between 40 and 60? 20. So that means I have 20 for my quote-unquote rise. But then, when you look over here, all I did was I took 60 minus 40 to get 20. That's all I did. But then, when you look over here, what is my run? 4. So that means if my rise is 20 and my run is 4, what is my slope of this? Thank you. Now, 5 is my slope. What does it mean in this word problem?
Each time you use the pool.
Hold on. Say what? There you go. It is what you pay every visit. Okay? That's what you pay every visit. So I'm just going to say the price per visit. Now, did somebody ask me where I got the 5 from? Where did I get the 4 from? Okay. The 4 comes from me looking right here. When I go over here, I'm at $60, but it was at the 4. So When I run, I'm running over to 4 hours. So now, if I told you to put it together, slope-intercept form, that's where we're going to have the y equals mx plus b, right? So, what do I have? Thank you. 5x plus 40. Stop and process. That is just writing the equation. Slope-intercept form. Now, this is where we're going to do a little application. For some of you, you're going to be able to figure this out without an equation. So, because you just can reason through it. And that's fine. But for some of you, you're going to know, okay, what am I substituting in this equation? Like, what is what? If I'm telling you, you said what? The y and the x, well, it depends on what they're asking for. Because if they're asking for the number of visits, they want you to find the x. Okay? If they're asking for the number of visits, you are to find the x. Which means they're giving you the y. Yeah. So in this case, they're asking how many visits would you have? So that means how many times or visits you're going to have had, to get to $210. Okay. Like I said, some of you are not going to use the equation. You're just going to figure it out, and I'm okay with that. The only reason I'm putting the equation up here is because for some reason, there are times when people are like, I don't even know where to start. But if I'm telling you that the 210 is the y, because we talk about money, the y is the money, then I'm putting 210, and then in this equation above, equals 5x plus 40, and I'm just solving for the x. This is if you want to do an equation. If you want to reason through this and know that you have to take the fee away and divide by each cost, I'm fine with that. This right here is this is not really a word, but this is a mathy way of solving it because you're simply solving the equation. But some of you don't need to do this because you're thinking in your brain, if I spend 210 and subtract the fee, then what's left here, 17, forgot. What's left here is divided by what I'm paying each time I go. But when you work the equation, y'all, you're doing the same thing. Working this equation would require I do the exact same thing because I would be subtracting the 40 and then dividing by 5. So, 170. Now, when you divide by 5, how many visits?
34.
That was 34.
34.
Yeah, right, because I'm hearing 35. Okay, maybe I heard the wrong thing then. Oh my gosh. Okay. So sometimes, look, if you don't have a membership fee, sometimes if you pay each visit, it's way more than that. So you end up saving if you decide you want to swim a lot. Like, I'm totally getting off the task right now. I'm going to say about getting Chandler. Focus. The second problem. Okay, we're talking about my boy Austin. He's traveling to Nashville. The number of hours, please read. If you're not reading out loud, read to yourself. The number of hours since he started driving is represented by X. The Y represents the distance he's from Nashville. So right here, again, number of hours since he started driving here. So basically this is saying after 1 hour of driving, he's right there at that many miles. After 2 hours of driving, he's at that many out. You understand? After 3 hours, that's where how many miles he is. So he's getting closer to his destination. Getting to Nashville means you have 0 miles left, okay? That means, for one, we know that our rate's decreasing because the distance is decreasing. So can you tell me first the y-intercept? Let's start with that.
600 miles.
And now you gotta tell me, what does it mean in this situation? I heard it. How far he is. How far he is.
How far he is from right.
or how far he lives, I guess I could say, how far he lives from, Nashville. All right, remember when I showed you on the slope from last time? I'm gonna do it the same way. Miss Owens. So look right here. Can you tell me the slope?
75. No, 30. 600. Hold on. So sorry.
Let me draw a little dot right here.
It's 30, yeah.
Okay, so make sure everybody's with me. You understand if we're going, oh my gosh. I cannot. The distance from here to here, you're going down 150, right? But that's 150 in, was it 2.5 hours?
Yeah.
So if that's 150 in 2.5 hours, the slope is negative. Did you not tell me already?
We did, I did it.
Oh, you did?
Yeah.
Oh, okay. Well, how'd you do it? And you got what? But what did you divide by again? That's right. That works that way because it's still the same answer. But don't forget it's got to be negative. So this right here is negative 30. And then you got to tell me, think about this. What is the meaning of negative 30 in this word problem? Don't say it's the rate. Don't say it's the rate. Oh, did it? Oh, is it supposed to be negative 60? Hold up. Oh my gosh, it's not 30. How did I get that? Oh my gosh. It is negative 60.
Right. Where you get 2.5 from?
Can y'all show me?
So is that how many miles per hour?
Thank you, Jalen. It's negative 60. Okay, so, huh? Oh, I don't think this is exactly at that part though. This is not exactly on there.
Yeah.
No, I don't think that's exactly on there.
So we ain't.
I think it is.
It's distance per hour.
You went up to.
But look at it like
It
this.
would be.
I went
If
down
you wanna,
and I went with 5.
That's the
you said
error.
what?
It would be.
That's how I got my she did 155.
But did you get negative 60 though?
No, I got 30. But she did.
So then that means you want to look at it from here. Baby, you know what this says? This says that after 2.5 hours, he has driven, well, he's 150 miles closer, let's say.
So that's how many miles per hour he's got. It's negative.
Well, I can.
That would be 5 times 20. That's where I got 5 from.
Okay, when you say 5, what do you mean 5? Are you talking about 5 blocks?
Yeah.
Yeah.
Okay, thank you. Now I understand. Don't look at 5 blocks. Look at the fact that this is 2.5 hours.
Oh, okay.
See?
Okay. So why we didn't look at that up there? We looked at.
Because it was by 1 unit down
Well, I literally looked at the numbers up here. I took 600 and subtracted 450.
Yeah.
That's where I got the 150, but negative 150. But then I divide by how far I went over here, which is 2.5 hours. So negative 60 is my slope. Thank you for getting me straight on that. But what does this mean in
there.
this?
How many miles are losing per
How many miles he's going per hour? So
But it's
basically,
like he's losing those. Like that's how much closer.
yeah, because it's knocking it off his miles to get there. You think about that like for a second. 60 miles is getting him closer. Every hour he's getting 60 miles closer. So we're just going to say that is the number of miles closer per hour. I'll say that. If you are writing slope-intercept form, you got a y equals, and then you have to substitute your slope and your y-intercept. Say it again, negative 60, thank you, plus 600. This is my equation. Again, part D, you really don't have to substitute the value in the equation. You can just figure it out based on the number of miles it takes to get there and how many he's knocking off. per hour. So you could just do it that way and divide. But if you were wanting to look at the equation aspect, if I'm asking how long will it take, is asking for the time. The time is the x. So you're trying to find what the x value is. If you're trying to find the x, that means they're giving you the y. Well, let me think about this for a second. What is the y value once he gets to Nashville? 0. So he's at 0 miles. If I put this in the equation, which I told you is not necessary because you can do it mentally, you are going to say that 0 equals negative 60x plus 600. And this might be more confusing to some of you, really, because if you know 600 miles divided by 60 will tell you the time, you can do it that way. Or somebody said, "Maybe I didn't do that." I said, right here, 5 hours gets him halfway there. So 5 more hours gets him all the way
That's
there.
what I had that right. I don't know if you heard me say it, like, before you started today, I was like, the answer's 10.
Again, that's why I was saying this part right here to me is unnecessary when it's something this simple. You can just do it in your head. So it's 10 hours. And if you reason through that, thank you very much. Like, I'm thanking you for doing something against me. Seriously. Okay, one more, and then you're going to do the last one on your own. So flip to the back side. Don't moan, don't groan. Come on now. You're doing too much.
Can you go slower on the lower?
Sure. There's another negative code, so we'll do this one.
I don't know how you can find it.
Okay, so what you're gonna have to do is look on the y-axis and subtract that point from the wherever you start in the other point, and then look on the x-axis and read the bottom from where to where am I going, okay? So in this case, you know the y-intercept is right here. I'm gonna put a mark. Bless you, whoever that is.
Appreciate it.
And now I'm looking at this point here is where my run would be. So Harmony, and not just Harmony, but anybody else, if you are starting at 360 and you
So 120,
run down here, how far was that? I heard somebody say it.
about 7.
No, I meant like, what is 360 minus 240? It's 120. But since it's going downward, y'all, it's negative 120. Now, Harmony, and not just Harmony, I think it was someone else that asked, if I'm going over, you were counting the blocks last time. Even though counting the blocks works this time, don't count the blocks. Instead, look at the number here. There we go. So it's just 120 divided by 5, which gives me the rate, which I didn't really ask for first, but kind of got a step ahead of me. Let's write all this down.
Hey, Ms. Bridge, I'm confused.
What's up?
Why didn't you go all the way down to the arrow? Like,
Yeah, why did I put it that way?
Oh, you can. Yeah, you can. I just went to the first thought I saw. Since this is a linear equation, the rate is constant. It really didn't matter which 2 points I used. So I'm glad he said that. You could have went down there. Did you not get the same answer?
I did. I got
Okay.
120.
There you go. So you understand. If you go,
120. That's what you got, right? The same answer. Look,
You
I
did?
did.
Okay.
300 I did 360 minus 240.
Oh, I thought you were saying that you went all the way down here, though.
No, I did.
Okay.
I did. I went down from 360 to 102, and then
So I was thinking that you said that was 120.
Oh.
No,
I misunderstood you. I thought you were saying that from 360 to 120 was 120.
Yeah, you do all the way
So,
down.
I
yeah.
heard a lot of ooh.
Totally
The
misunderstood.
right answer.
That's right.
Oh my gosh, that was so crazy. What is the y-intercept?
360.
360. Now, I done sat here and got the answer and didn't even read the word from it. Y'all. Go back. Make sure you understand what it's saying. Okay. Up here, lock in, please.
The starting temperature?
Now, when you say the starting temperature, you understand that that's the starting temperature after she takes them out the oven. This is kind of confusing, so you really need to think about this. It's saying that she made cookies, she took them out the oven at 360 degrees. So that's basically what you're telling me. I mean, that's obviously the temperature she must be cooking them on. But when they come out of the oven, they're at 360 degrees. So that's what I'm going to write. It is the temperature when they come out the oven. Now, we already know what the slope is. We count that first. It's negative 24.
And you got that by doing 120 divided by 5?
Now, what does this mean in this word problem?
The temperature decrease per minute.
Yes, that is the temperature that the cookies are decreasing per minute. So, temperature decrease per minute. Now that you have these two pieces of information, you can write it in open instruction. You got a Y, you got an equal, you got an X. You got to put the numbers where they belong.
Negative 24. X.
That's right. And then what else? Did somebody say it?
Plus 360.
Thank you. Plus 360. That's a big old X. That's a big old X. Hey, yo, would you please think about the next one? Again, you can figure this out without an equation, but understand they're asking for what temperature will the cookies be 12 minutes after they come out. So if we're looking for the temperature, y'all, the temperature is the Y. So if you're using this nice little equation right here, if you're using this, we're solving for Y, which means they're giving you X.
So you substitute the extra one.
It's 72.
If they're asking for the temperature, that means they're giving you
72.
the X. And I think I heard the right answer.
72.
Yes, that's it.
Modern math.
Oh my gosh! Don't use my mama laugh like that.
That's what he said.
I thought it was, don't mind me.
I did the math and everything. I was so sure of myself. And it's not what
Question?
Yes.
Excuse me? Thank you. Questions?
What is that?
I'm
Y'all got the next one on your own.
No.
No, I was telling you, not asking.
What's the?